move forward, we've seen a lot of automotive and ancillaries related papers till now. There's a small change here. It's not just delimited to automotive world or aerospace. So we can see in the next paper from Larsen and Toubro, engineering construction, how they do the structural modeling and meshing of blast furnace using hypermesh and supported TCL/TK formats. I would like to call upon stage Dr. Devi Prasad Ghosh. I personally know him, and I've seen him work on multiple platforms in the past. So, over to you, sir.
Myself, Dr. Devi Prasad Ghosh, our head Bhaskar Sengupta, Dr. Syam Krishna Mitra, and Sujan Hajra is the co-author of this paper. Topic of this talk is structural modeling and meshing of blast furnace using hypermesh and TCL/TK. I am from Technology Cell L&T Construction, M&M SBG, Kolkata. Technology Cell is under our Vice President and Head M&M SBG, Mr. Derek Michael Shah, headed by Mr. Bhaskar Sengupta. Myself and Dr. Syam Krishna Mitra, we are mainly finite element and optimization and inverse problem side. Dr. Tanmoy Datta and Manoj Lal Das is basically handling CFD, DEM, and their coupling, multi-phase flow, reactive flow related issue. Sujan Hajra is a metallurgist, so he is dealing with mass and energy balance of the blast furnace. Dev Shankar, Shovik and Ankur, they are basically trying to integrate in-house model in the level 2 automation system. So this is our, so already Nitin has told, so this is not car or any component of the car related things. This is a blast furnace. Blast furnace is a counter current gas, solid, liquid reactor operating at high temperature and pressure. Solid charges from top, reducing gases generated at the bottom by combustion of carbon either as charcoal or coke. Anyway, I am not metallurgist. So blast furnace has mainly in 5 different parts. At the bottom is hearth, where the liquid metals are stored. At the top, it is throat, from where this top gas comes out. At the middle, it is belly. This throat, belly, and heart is parallel section. Inverted truncated portion is boss, and truncated portion is sap. So objective of this paper is basically programmatically we want to create solid modeling of the blast furnace structural part, and then meshing, applied different kind of loads. To then it will be pushed into the ANSYS solver. ANSYS will solve, and then you'll see the result in the hyperview. All these things will be automatically. That is the basic idea of this paper. So first thing is solid modeling. Traditionally, blast furnace is designed with some set of standard dimensions, and that is the way it is going on. But we are trying to make it in some free site, such that we can operate with these dimensions. So that thing we have put it, we have given in the as a tabular format inside that hypermesh. So we can change this dimension anytime. And obviously there are 3 different standard techniques is also there. It is available in the literature how we can do it. Then this is the meshing technique. 1/4 of the blast furnace solid model will be was meshed using map mesh, such that we'll get better quality brick and word elements. Then it was reflected in XY XZ and YZ plane to get the full circle. And these are equivalent such that two nodes in the same place. This is just to get the 3D bricks, and then to get the such that 2D elements should be in the same node of the 3D elements. We have face lifted surfaces from the 3D elements. Different boundary conditions, like at the bottom is the fixed surface, fixed support. Internal pressure due to the blast furnace inside gas and whatever the burden. Similarly, the internal temperature also, cell weight and burden load, and seismic load due to cell weight and burden loads. Fire bricks are highly nonlinear or highly temperature dependent property. So we have used a table where we can give different property for different temperature, mainly in elasticity, density, Poisson's ratio, conductivity, and thermal expansion. For cell, generally we use steel cell. Finally, once we have created this model and meshing boundary condition, we push it to ANSYS, and that ANSYS should be solved from HyperWorks itself. We don't have to go outside of that. For that, we have used this exe comment within the try block. So this is the batch file, and this is basically the comment. I'll come to the result later. Once I get the ANSYS will solve, ANSYS will give the either .rst or RTH file, and that RST and RTH file will be opened in HyperView with this following comment. This is just a session file. Okay, this result is, if I want to explain, we have given a seismic load horizontally, and due to that horizontal load, this is the displacement contour. So the here is the maximum displacement at the top. This is the displacement contour, and this is stress contour. And maximum stress is the connection between Bosch and the beam. I have movie, 3 minutes movie. I have used script view, so extensive namespace was used here. Just if I just type this, so different tabs will come here. This is the problem of all softwares. What is the frame size it will take? So here I have given material, automatically materials has come. So already I have told how I have made it. Boundary condition was imposed. Different load collectors was automatically generated. already exposed to ANSYS and solving. This is the tab where we can put what are the internal temperature, pressure. Automatically HyperView has opened. What are the challenges I have faced? As a TCL-TK is not object-oriented, so it's difficult to develop, reuse, maintain, and extend. But we have used extensive namespaces and creation of different components and load collectors. Script view is a good help. And another problem is HyperMesh, ANSYS, and HyperView interoperability. This is a common problem. Conclusion, computational framework to model blast furnace reactor cell using TCL-TK, HyperMesh, ANSYS, batch solver I have used, and HyperView to view the things. The automatic modeling technique to concentrate on important design related issues, which will reduce manual error with the automation and different customization, customized optimization. We thanks Altair teams.
I will open for questions.
Done this whole simulation cycle without using this, whatever you have developed now.
Without using?
Without, see, now you have developed something
and
you're using it. Now the same thing, was it done prior to this process too?
Okay. So directly we have used it, we are using this automation.
Oh, this is the
so
first,
we don't have
okay.
any comparison, means
No comparison.
without automation and with automation.
Okay.
We don't have that one.
But what prompted you to think about it this way? Of course, it's logical and it makes sense, but what kind of challenges you would have had if you don't have these tools now?
Oh, we
Yes.
don't have this one.
Yes.
Oh, we have to do it manually, everything.
Okay.
Everything we have to do manually.
Any idea what kind of a
Time, it will,
time, yeah, roughly?
time frame wise, not only time frame wise, means the main thing is design related issue. We can make it mean lazy decision, means we can take the decision later on.
Okay.
What will be the thickness, what will be the this thing we can do later on. That is the main advantage of it,
Okay.
automation kind of thing.
Okay. Otherwise you will have to...
Otherwise we have to, initially we have to decide what is the this thing, what should be the dimension, what should be the this thing.
Okay.
This thing we have to decide.
Okay. So even CAD geometry gets generated from
that
this?
we don't have. Basically, DM and others, they have old, legacy CAD geometry. We
Right.
don't have that one.
But do you generate some CAD geometry as well from this? No.
No, directly.
Just an analysis model that you use. Okay. Yeah, thanks.
Hello, good afternoon everybody. I am Parmesh from HCL, working for Aero Engines. Just I want to know, like you are plotting the temperature in the RST file or RTH file. I was not in a position to plot them in the HyperView. So just I want to know whether you have created a separate TCL script or what is the thing, how you are plotting the temperature for the model.
Temperature.
Solved model. From
Temperature?
the result file, yes.
Temperature, HyperView. In our, whatever we have, we have not been able to plot temperature. So these are the stresses and replacement.
Okay. Thank you.
Actually, HyperWorks does support TCL. You said that it's not object oriented, right?
Okay.
There's something called ITCL that is object oriented.
Yeah.
This is just a suggestion.
Yeah. Yes,
Any other questions? That was a very good demonstrator, I must say. Very good video also supporting it, the entire process. Thank you, Mr. Dr. Debi Prasad Ghosh. I would like to welcome on stage Rajesh Krishnan, who is our head ESG, which consults and which handles all the consulting and process automation services business.